Hello everyone. Let's go over chapter 8.1, Systems of Linear Equations and Graphs. So let's go over the definitions first. System of linear equations refer to when you get two or more linear equations involving common variables, such as x and y. Those are two common variables. And the solution to a system of linear equations is essentially when we're looking for a point of intersection of those lines that they give you, the systems of linear equations, or ordered pair, which is a different term to use for coordinate, and a pair of values, same thing. So essentially what they're saying here is finding coordinates that these equations, when graphed, intersect. Let's take a look at example 1. Solve using a table of values and verify using a graph. So we have an online music store that offers two payment methods. So the customer pays a monthly subscription fee of $8 and songs can be downloaded for 70 cents each. So the equation of this would be the total cost equals the monthly subscription fee is $8, so that's where we're starting at. And if we were to label the number of songs as variable n, this is number of songs, we know each song costs 70 cents, so 0.7 times n would be the total cost. So rewriting this with just variable, so C equals 0.7n plus 8. And this is in slope-intercept form. That's why I just rearranged the order. Let's take a look at number 2. The customer pays as you go at a full rate of 90 cents per song. So now we have cost that equals to 90 cents per song. So you're paying every time you purchase a song. So 90 cents each times n, number of songs. So how many songs would have to be downloaded for the subscription plan to be better deal? Okay, so let's take a look at this using table values. So subscription, we have the original equation was C equals 0.7, I think, yeah, n plus 8. So what we're going to do, we're going to plug in n equal to 0, and then we'll go up by 10, just because we need to check for higher values of n. And we'll just keep the same thing here for pay-as-you-go as well. This time, our equation for pay-as-you-go is 0.9 times n. Okay, so notice that cost is in terms of n. So cost depends on number of songs you download. All right, so we now just need to plug in when n equals 0 into the equation C. Notice that I'm using a function notation here, so I'm not necessarily multiplying C and 0. It's to notate that C is a function in terms of n. N is 0 in this time. So 0.7 times 0 plus 8 is just 8. And you do 10 here. N equals 10. 0.7 times 10 plus 8 is 15, and so on. So I'll just fill these in for you so you guys could do your calculation separately. And when we take a look at pay-as-you-go, when number of songs is 0, so n is 0, then our cost is also $0. So when you do plug in n equal to 10, then you get $9, and then it goes up by 9 every time. All right. Let's try graphing these or plotting first. So I'll use red for subscription and pink for pay-as-you-go. All right, we first need to set our axes. So our independent variable is n. So n goes horizontally here. So n is number of songs. And cost is dependent variable. So C, where this is in dollars. All right, so let's set our increment. I'll set n goes up by 10 because that's what we kind of set it up here. So it starts at 0, goes up by 10, so 30 and 40, 50, 60, and I'll do the same thing for cost. We'll go up by 10, so 10, 20, 30, 40. I'll go up to 60 for now. Now starting with the red one right here, subscription, n equals 0, then cost is $8. So right here, when n is 10, it's 15, 10, 15, right here, and 20 and 22, and so on. So I'll plug in 60 and 50 first. So 60 and 50 right here. So this way I can kind of like see if my lines are straight. Here, let's see. Oh, it's pretty good. So let's go this way, and this is subscription. Okay, so if we were to plot it, it should be around here somewhere as well. For the pink one, pay as you go, when n is 0, cost is 0, so we start at the origin. And it's 10, cost is 9. All right, it looks good, and you continue. So 2018, so somewhere here. And you know what? I'm just going to go all the way up to a value I know, 54. Okay, 60 and 54, somewhere here. All right, so let's try connecting those points. Okay, close enough. Okay, there we go. All right, so this one is pay as you go. All right, so notice that we have an intersection. Well, on my graph, it looks like it's here, but it should be here. So we could state that our intersection happens at 40 and 30 something. Okay, so let's take a look at our chart. So it happens when n equals n. So it's 36. So this coordinate here, I'll use blue. So this coordinate, the intersection is 40 and 36. Notice that subscription fee was higher in the beginning. And then after this point, after 40th song, it's actually a better deal compared to pay-as-you-go. So we can conclude that subscription fee or plan is a better deal if you download more than 40 songs. Moving on to example 2. Solve graphically and verify the solution. So part A tells us to graph using slope-intercept form, and note that this is y equals mx plus b form. All right, so let's take a look at this one. So our two equations are already in slope-intercept form. When we're graphing these lines without, like using a table of values, we can actually first start with slope. So for this case, slope is -2. And b, which is a y-intercept, is +2. So we can actually start graphing this right away. Notice that horizontal axis is x and vertical is y. And b is y-intercept. Therefore, let's say this is +2. So y-intercept happens at 0 and 2. And the slope is rise over run, so it goes down 2 and 1 to the right. So we go 1, 2, and 1 to the right. So we have new point right here. And then you continue the pattern this way. And we're going to connect the points. All right, so this is our first line. I'll use pink for the second line. We're going to do the same thing here. We're going to list the slope. So slope is, because there's a hidden 1 here, we just don't write it. So it's 1 here, slope is 1. B, which is the y-intercept, is -7. And notice that our grid here is a bit small. It doesn't have, it only goes up to 6, -6. So we do need to make a new point here. I'll say this one is 0 and -7. Okay, and then we're going to follow the pattern of slope. So we go up 1, 1 right. Up 1, 1 right, and we're going to continue this way. All right, we already see an intersection here. So that's good. So this is our intersection, which is a solution to the linear system here. All right, this coordinate is 1, 2, 3. So +3 and 1, 2, 3, 4, -4. Okay, so the first thing we did was to graph. And second step we did was find intersection. And once you find this, you do want to mention that intersection happens at 3 and -4. Okay? And and this is because they want us to solve it graphically, so you do have to mention it this way. And they wanted us to verify the solution. And we're going to verify by substituting into both equations. So we had a point of intersection, x and y. This turned out to be 3 and -4 from the previous part. That's how we solved it graphically. So we're going to now go back and plug it into the equations to see if it's actually valid. So the first equation was y equal to -2x plus 2. And then we're going to sub in y as -4 and x as 3. So -6, 2, -4 here. And hey, this turns out -4 equals -4. So this is valid. So yes, it works in this equation. Let's take a look at the second equation with the same point. So we have this equation now. And sub in y equal to -4. X is 3. Hey, they do end up become valid. So we can then state that we have verified the solution set to be set is 3 and negative 4. All right, now moving on to example 3. Solve graphically and verify the solution. And this time they want us to use intercepts. Let's take a look. So there's two equations also in slope-intercept form. So we know from this y equals mx plus b, we know that b is y-intercept. So we can state that b is 1 for the first equation, and therefore the y-intercept happens at 0 and 1. Okay, so we don't have to really calculate it, but you can by plugging x equal to 0, but we don't have to because we're given here. So we found this already. Let's actually look for x-intercepts, or intercept because it's a line. So x-intercept happened when y equals 0. So all we need to do is plug in y equal to 0 to the equation. So 0 equals 1 over 2x plus 1. And we will need to get rid of that denominator first. So I'm going to multiply the entire equation by 2. And we get 0 equals x plus 2. And then I'll take away 2 on both sides. So we're left with x equals negative 2. So x-intercept happens at negative 2 and 0. Okay, so this is x-intercept. All right, let's first plot these two intercepts. So we know x and y here. Y-intercept happens at 0 and 1 right here. And x-intercept happens negative 2 and 0, so right here. Let's connect these 2 points. Okay, but make sure your line is a bit longer. Okay, so it does look stretched this way. We do need to see the intersection, so it has to be long enough. And sorry, there was a typo here. So the second equation is actually y equal to 3 over 2x minus 1. The first given equation, we can't really graph it well, so I had to switch it. All right, so anyways, let's use this as our new equation 2, and then we can see that b is negative 1, which indicates that y-intercept happens at 0 and negative 1. All right, then we need to solve for x-intercept by plugging in y equal to 0. So sub in 0 into y, so we have 0 equals 3 over 2x minus 1. And we want to isolate x, so this time you can actually add 1 first on both sides. Before I just multiply the denominator to the entire equation, but there's this way as well, so I'm just showing you 2 different ways to do it. All right, and now we're left with 1 equals to 3 over 2x. Now we're going to multiply entire equation by 2. So we're left with 2 times 3x. Then you divide 3 on both sides to get x equals 2 over 3. And it is okay to have a fraction as a, one of the value of coordinate. So it's safe to say that x-intercept happens at 2 over 3 and 0. Okay, so let's plot these two intercepts. Y-intercept is at 0 and -1 right here. And then x-intercept happens at 2/3 and 0. So 2/3 is like right here. All right, let's just connect those 2 points. Let's see how this goes. Oops. Resize. Oops. Oh, okay. Okay, that was hard. Right here. Wow, okay, so our intercept is not that good, but it should be right here. Yeah. So it's crucial to draw a correct graph, guys, so make sure you do it carefully. And so notice that this is our intersection. The coordinate is 2 and 2. So solution set is 2 and 2. Now it's time to verify if 2 and 2 is actually the solution. So let's take a look at part B here. We're going to follow the same step as previous example. So verify if this point, 2 and 2 is actually indeed a solution to the linear equations. So first equation was y equal to 1/2x plus 1. So I'm going to sub in x and y, like 2 and x equals to 2, and see if this equation is valid. So we have 2 equals 2 times 2/2 is 1, 1 plus 1. 2 does indeed equal to 2, so it is valid. And the second equation that was in pink, we have y equals to 3/2x minus 1, and sub in y equals to 2, and x equals to 2 as well. And here you cancel these denominator and the numerator here, so we are left with 3 here. Oops. So 3 minus 1 equals 2. Okay, so this one's also valid as well. So we have verified that the solution set is 2 and 2. So that's it for today. I'll see you guys in the next video.